Hey folks, welcome to our channel. This is Offgrid Van Life, where we look at van conversions, motorhomes, campers, off-grid power, lithium iron phosphate batteries, and all of that sort of stuff. Basically, we want to help you and provide a resource to help you to build out that perfect van and be able to have a power solution in your van that you can run a really good coffee machine or whatever you need to do in your van. So in this video, we're going to be looking at this, which is a battery that we built. So if you've been subscribed to our channel for a little while, you may have seen the live video we did recently where we actually built this out from scratch. We talked through the whole process of how we actually do these, and it was just a live walkthrough as we were building out this battery to test it. And essentially what we're doing with this is we're testing this case. So this is a metal case that we got. I've had a few people ask for the link for this case, and I don't actually have a link because this case was custom made for us to order. So the supplier that we use to supply our battery cells put this case together for us as a prototype, and we're in the process of testing it out to see if it's something that we're going to be using long term for some of our battery builds, and if we can potentially recommend it to people to help them out. So I'll talk you through quickly what's in here before we actually get to
I'll hold it up
to building it out. But essentially we've got 4 EVE cells, so these are 280 amp hour cells. This is one of our favorite brands that we've been working with recently. They're really solid cells, really good performing, high capacity, and we just really like them. And then on the side here we've got a 200 amp BMS, so it's a DALI smart BMS. It has the Bluetooth module, so you'll see we'll connect up to Bluetooth in a moment. It has this little module here which just plugs into a USB cable that we're going to put through at the top of the case here. And this battery we've assembled in a plywood clamp, so we've got threaded bar down each side, so 4 threaded bars and a piece of 9mm, or what's that, like a 1/4 inch plywood on either side, just to clamp the cells to stop any expanding or anything like that. And in addition to that, what we also have done is we've top balanced this battery, so it's at a full state of charge now. So we're going to get this battery closed up and assembled, and then we're going to be running a high capacity test. So in this video we're going to hook up a 2000 watt Guayandel inverter, and then we're going to hook up a heating fan, put it to its max. We know that this heating fan will draw about 170 to 180 amps at its max setting, which will be very comfortable for this battery to withstand and for this BMS to cope with. And so we're going to max out what that heating fan can do and basically push the BMS to almost its limits to test to see how well it works. So this is the first test we're doing in this case. What we're trying to see is, can the battery run at its almost maximum capacity for the full amp hours that the cells have in them to then discharge. So it's a very high C test, and we're going to run that and see what happens and see if the BMS copes with being in this box or whether it overheats or anything like that. So we're going to start off by putting this lid on here.
We're also going to use these probes, just simple, they're cheap temperature probes. We're going to attach them in various places because we want to know what's actually happening temperature wise. The main thing we want to know is on the main positive terminal what the temperature is on that.
Yeah, so we're going to start off by just connecting our cable that's going to the lid, to the terminal on the lid here. So this is just a very thick cable. It's a 1/0 gauge, or 50 mil squared, and we're talking all of the nuts on these terminals. They laser welded studs on these cells. We're talking them to 9 Newton meters, which is the what we have been recommended by the manufacturer. Okay, so that's torqued down nicely on that. And then we are going to do this one here, which is going to go through there. And then the cable coming out of the BMS is fairly short on this So it's a bit tricky. And that tilt down like that, just so that I can get into the side here. Okay. Now let's
just mount this one probe onto here. Just going to put it right onto the...
Can you pass it through this hole here?
Yeah.
That way we can hold the... We're not going to screw the case down just because we want a few of these temperature probes in the actual case. We're going to put one on the actual terminal, on the main positive terminal coming off the battery here. Is that a nut?
Yeah. There's a nut. On the side. Let me get to it. Let's see if I can get enough thread to tighten it down a bit. Yeah, that's enough on that. Okay. And I want another probe just floating on the top.
Just going to test the voltage on this. I don't think the BMS is turned on yet. You got that?
Yeah.
So just on these terminals on the top here. So 3.8 volts, which is what we would expect. The BMS is not on, so we haven't actually even plugged in the balance lead. So that's one thing just to note, just as an aside. If you're doing any maintenance on your battery, unplug the plug that goes into the side of your daily BMS, so that the BMS turns off essentially. It's just a bit safer than you're working with lower voltage. So 3.3 volts, which is what we'd expect with the BMS off. We've put in this little on switch, so it's just a very simple third-party switch with a plug that goes into the side of the daily BMS. So if I push that once and then check the multimeter again, we've got 13.9 volts. So these cells have a full state of charge, but they have settled since this morning really. So they've sat and settled down to that voltage. So temperature probe is in a good place for the actual BMS, I think. Let's just double check.
So for this we're going to measure the temperature of the BMS itself, not of the cells. Normally you'd place the probe over the cells because you want to protect the cells.
Where is it? Oh, it's there.
But because we have two other probes over the cells, that'll tell us enough.
Okay, we're done.
Yep. Where did the Bluetooth dongle go?
It's over here. So we're going to plug in the Bluetooth dongle, and then we should be able to connect to it on the phone and see.
There we are.
Just need to adjust this. Okay, coming off the BMS here, it's at too much of an angle to actually close the case.
So this is fine. Bluetooth has come on.
Close that now. That should close. There we go.
Cool.
It's very lightly over here. Okay, that's that alright?
Yeah.
Alright. All sorted on that. Now what we're going to do is to connect a Victron Smart Shunt, which is what we are going to actually use to actually just monitor and check how we're doing and how many amp hours we've used.
So the temperature is sitting at about 20 degrees centigrade.
Just okay, 13. That's 14. These are really nice solid terminals. It's a M8 terminal and copper at the bottom of the terminal, so it's really nice. I'm pretty pleased with those. All right, let's slide this over just a touch here. Clear some space for our inverter. Okay.
Something with a big washer.
Bit of an overkill bolt for this, but I didn't have another M8 bolt for this test, so that's what we're using.
Should be good.
All right. Okay. Connect our inverter here. Make sure we don't bridge any of the terminals, the positive and negative, and create a short. If you have access to insulated tools, it is advisable to use those, because all you need to do is swing the spanner around, hit the other terminal, and then you'll have lots of fireworks going on. Okay, and then our terminals here, so the white one is reading 19 degrees Celsius, which is pretty much the ambient temperature of the room here, and that's the one that's connected to the positive terminal on the battery. And the same, the black one is the one that's just sitting on the top of the battery inside, and it's also reading 19 degrees. So I'm going to get this heating fan going here. Put that over there and turn the inverter on. Right, there we go.
So we're running at 0.82 amps now, so less than 1 amp for the inverter to be on standby.
Yeah, these Guindel inverters are very efficient. If you're looking for a good inverter, definitely recommend those. So that's the fan at its first setting, which is 80 amp hours draw. You can see just over there, that's the draw coming off the battery. And if we put that up to the next setting, it takes us up to 160 amps draw over there. So if we leave that for a couple of hours now, that will deplete the battery in probably 2 hours, thereabouts.
Just less than 2 hours, about 1 3/4.
Okay. And we'll keep an eye on these temperature probes. They obviously still just sitting at the ambient temperature, which is to be expected because we haven't had this on for very long, but we'll probably see the temperature rise relatively quickly now, and then hopefully it'll just sit at around probably 40 degrees Celsius and no hotter than that. But it'll be a good indication to see how well this case actually does and how well the BMS does in an enclosed case like this. We drilled a hole in the top of the case to allow the Bluetooth from the BMS to come out, which we would then land up probably just sticking to the top of the case or something like that. Put a grommet around the metal around where we've drilled the hole. But yeah, we're gonna keep this test running. Already the white one, which is connected to the positive terminal on the end of the series, is already going up. It's at 20.2 degrees Celsius. So we can already see it's going up. This one here, the black one, which is just sitting on the top of the cells, is already at 20 degrees, 20.1. So already the temperature is rising, but we'll keep an eye on that and just see. The BMS has a temperature cutoff built in anyway, so if it does get too hot in there, then it'll just turn itself off anyway to protect it. So you don't have the risk of the thing exploding or anything, because that's what the BMS is there for. It's to protect the cells and make sure that they don't get too hot or overheat or anything. But the purpose of what we're trying to see here is, can you build out a battery in a case like this really well and easily, and have a really high performing battery? I mean, 160 amps, it's a very large draw, especially to have that continuously for like 2 hours or almost 2 hours. Not many people will draw that level of amperage for continuous time like that. So this is the DALI app that we can see there. So state of charge, drop down a little bit, and we can see the draw there is just under 170 amps, so pretty much in line with the Victron Smart Shunt.
And most importantly, this is showing us that we're at 19 degrees centigrade on the BMS. We're at 21 now on the positive terminal, to be expected, and slightly less on top of the cells. The positive terminal will probably rise by about 10-15 degrees through the whole test.
Yeah. Okay, so we'll leave that running.
And these, just for interest, these cables are already quite warm to the touch. Gandel, the inverters are absolutely brilliant. The cables, I don't like them personally because they always run hot, and I just don't like things running hot. I know they are rated at 200 degrees centigrade, these cables, but I like things to run a bit cooler.
Yeah, we would always replace the cables that come with an inverter with cables that we make ourselves, and probably oversize them just to be on the safe side. Obviously fused correctly and all that sort of stuff. But yeah, we just, for the purpose of the test, we're just running the cables that came with the inverter. But we can see the temperature rising, so 22 degrees now on that positive terminal.
And 20 on the BMS.
So yeah, it's still not crazy, but we'll update you guys as we check things and as the test progresses, and keep you posted on how this battery does. Okay, so this test has been running for almost an hour now. It's about 45 minutes or thereabouts, and we've drawn, if you have a look here at the Victron Smart Shunt, if I just come around and see over here, so we're still drawing just under 170 amps, and we have drawn 112 amp hours from the battery. So as I mentioned earlier, these cells are capable of a 280 amp hour capacity, so we're probably just under halfway from depleting the battery. In terms of the temperature, if we go over to the DALI app, temperature on the BMS, which you can see just there, that temperature on the BMS is 34 degrees Celsius, so that's well within the range, and very happy with that. The temperature on the actual positive terminal coming off the battery is 33, just under 34 degrees, so pretty consistent with the BMS, so that's fine, happy with that. The temperature just on the top of the battery with this probe is 28 degrees Celsius, so the temperature inside this box is very acceptable, very happy with it. Just feeling the terminals here, they are a bit warm to touch, but nothing crazy. It's not like scalding hot, but and the cable is fairly warm, but nothing too outrageous. As we mentioned earlier, these cables are capable of 200 degrees Celsius, so overall the test is going very well. We'll check in once the battery is depleted and update you guys on how it all got on. Okay, so we're nearing the end of this test here. So as you can see there, we have just hit 270 amp hours out of this battery, so very close to capacity, and the voltage is getting pretty low now. In terms of temperature, which is the main thing that we're testing on this, we're at 43 degrees on the red terminal inside the box, 36 degrees just on the top of the cells. The cables here are fairly warm to touch, and the terminal is quite warm to touch as well, the red one, but it's not like it's not unreasonably hot, and inside around the BMS it's 44 degrees, so pretty similar to the main positive terminal coming off the battery there, so getting pretty close to capacity now. So yeah, on the whole, pretty happy with the performance here. The case to touch is not that. A couple of places it's a little bit warm, like around here where obviously the heat is conducting there, and a little bit warm here where the BMS is, but it's not, I mean, when I say a little bit warm, it's just not sort of ambient temperature. But I mean, in terms of a test, nobody is really going to run a 2000 watt inverter at almost full capacity for over 2 hours, or around 2 hours anyway. So there we go.
The inverter is, just turn the fan down, because the inverter is these cables are really hot, and there's quite a bit of voltage drop down the cables. The inverter is showing 10.5 volts now, but the BMS is still showing that we're on 11.2, 11.3. So there's still some way to go. We're on 276 amp hours. Bear in mind that we had this cutoff at 3.65. The standard, the BMS default is 3.75, and we stopped the discharge at 2.5, whereas the daily default is 2.2. So we have already restricted the capacity by a few percent. We're on 277 amp hours at the moment, so very, very close to the 280.
We're showing you just as it's nearing the end here, because as soon as the daily BMS turns off, the Victron Smart Shunt will reset, and we won't have a record of what the cells achieved or what the battery achieved. So 277 amp hours drawn so far, so we're easily going to hit the 280 amp hour capacity of these cells. So very pleased. It hasn't overheated, hasn't gone above the threshold for discharge that we've set on the BMS, which is the safety net to make sure that things don't overheat.
43.3 on the positive terminal, the degree centigrade, that is.
So that's 43.3 on there.
And the BMS says it is 44 degrees centigrade. That is very acceptable. Ambient temperature 20 degrees centigrade here. So we've gone up to 44 inside this enclosed case, running a very high C, well, pretty high C. So well pleased. The thing we didn't know was how well this everything would cope in this enclosed case, and we see the answer now. It's actually pretty positive. 279 amp hours at this stage, so just about hitting the 280 that is the stated capacity. We're on 10.6 volts at the inverter and 11.3 at the battery. So I think we're going to hit the 280 amp hours on this. 279.5 at the moment. On a high C test, to actually hit the stated capacity is a good thing.
Yeah.
I would expect on a low C to get at least 285, so to exceed the stated capacity. Temperature down to 43 because we dropped the fan. The voltage drop across this cable was just too much for the inverter to handle. The inverter was the one that was starting to shout. So we've just hit 280 amp hours, so really pleased.
There we go. 280 amp hours. So as we mentioned, we dropped the heating fan down to its first setting, which is drawing 95 amps from the battery. Mainly just because the voltage drop, as my dad mentioned on this cable here, the inverter was not enjoying that. So yeah, we're really pleased that the battery performed above the stated capacity at a high C test like this. So it's a very good step for this battery, first test of this battery. We're going to be doing a bunch more tests of this battery. My dad's going to be heading back to England and he'll be running tests there. So one of the tests that we're going to do is we're going to put the battery into our controlled temperature environment, and we're going to get the ambient temperature up to about 35 degrees Celsius, and then see what the battery does with that higher ambient temperature. And we'll then run a high C test at that temperature. Essentially what we're trying to do with that is to simulate somebody being in like Spain or somewhere like that where it's hot, and running a high C requirement from their battery, and to see whether this case would cause the battery and the BMS to overheat.
So our first cell is about to reach cutoff point. The inverter is shouting. We've reached 283 amp hours, and that is it.
There we go.
BMS has now stopped the discharge to protect the cells. Lowest cell got down to 2.5 volts, and it cut the discharge. That's already bounced up. Now that we've stopped the draw of the cells, they've bounced back up to 2.74 being the lowest. So the BMS has done its job. And what did we say, 283
amp hours.
283 on a high C test. I'm very pleased with that.
Yeah.
Nothing to complain about. That's great. 283 on a high C is going to give us close to 290 on a low C.
Yeah. So it's really good performance. Really pleased with that. As I mentioned, we're going to be running a bunch more tests. So yeah, if you're interested in seeing more of that, then hit that subscribe button and you can stick around, and we'll be putting those videos up over the coming weeks. But otherwise, I hope this has been interesting, and we'll keep you posted on the further development that we do with these batteries and more tests and all of that sort of stuff. So yeah, thanks for watching. We'll see you next time. Cheers.
Yeah. Cheers.